So the next example was something similar to what you were doing, which is a spiraling star. So now we're actually going to use the I in the for loop, right? So spiral is equal to turtle.turtle. For I in range 20, we'll move this turtle forward I times 10. So first we'll move him forward 10 spaces. We're going to move him forward 0 spaces, right? Because it's 0 through 19. Then we move him forward 10, then 20, then 20. And in between every time we do that, we're going to turn him 144 degrees. So notice that here he moves forward 0, turns 144 degrees to the right. Then, we start over here, turn 144 degrees to the right. Move forward 10, turn 144 degrees, moves 20, then moves 30, then 40, and it kind of so he multiplies I against it instead. So what's going to happen if you do I times I instead? Well, what is I times I? So that instead of being I times 10, that would be 0 times 0, then be 1 times 1, so it would be 0, 1, and 2 times 2, which is 4. So the amount, so this is a linear kind of growth right over here, where basically each step of the way it goes up by 10. But if you do that, it's going to go up quadratically. Meaning the growth rate will really change there. So you've got I times 2, right? So one thing you might want to do is I times I. Oh, and it's done with parentheses, by the way.
Is this one of those that landscape?
What?
Language symbols or that movie?
This is honestly probably not. There's both easier and harder ways to make symbols. Well, that's interesting, ain't it? And you're switching it between blue and red. So in case you're curious, my homework assignment here, which isn't going to be not necessarily too hard of an assignment, is I'll throw this up online, but my turtle homework assignment, which will be only with 50 points in comparison to some other stuff, because there's also going to be some other 50-point homeworks that I'll throw up online, is I want you guys to try to do the Olympic logo in Turtle, which is actually non-trivial, okay, if you want to get it a perfect match, right? Now, why is that non-trivial? And I won't necessarily expect a perfect match, but what makes it non-trivial? The overlapping. And it's not that any particular circle's drawn first, right? One circle's drawn over another circle, right? So it makes it kind of complicated. So if you want it, so doing the whole overlapping thing correctly, I'll consider that extra credit, and I'll write that up. But just getting 5 circles of different colors online, in the correct in something that looks rudimentary correct, that'll look good. That'll be good. So let's go ahead and see what we've got here. Okay, example, changing the line color. So here we import turtle, and he creates a turtle called Painter. Now again, so here's another thing. So instead of using color, he uses pen color, which doesn't change the color of the turtle itself. Instead, he just changes the color of the pen, right? You can control what color the turtle is and the color of the pen. So here again, he does this command 50 times in blue. Move forward 50, then go left 123 degrees. So I'm going to go ahead and copy that part over into this, and you can work along with me in this as well. So new turtle color .py, right? Import turtle Painter is equal to turtle.turtle. Although I could call it Bob again if I wanted to. Painter dot pen color blue. Okay. Although, yeah, and I'll go back here and start showing you how to mess with colors, by the way. I'll stop here and then we'll start being able to do custom colors after this. So for I in range 50, right? So we're going to do this command 50 times. We're going to move our little painter forward 50 degrees. Okay? And then it says let's go ahead and move him left 123 degrees. Turtle.done. Run it. Oh, pen color. Turtle has no attribute pen color. I have to use. Yes? Not too hard, huh? Google? Oh, somebody already did that one on Google? Well, that's no fun then. I'll have to find something else. Turtle.pencolor. Let's see. Oh, right. What was wrong? I used pen color lowercase. I had a C over here in uppercase, and they want lowercase there. That's a common mistake there. So he starts moving forward like that, and starts. So what is he doing there? He's essentially doing a 123-degree turn each time. So it kind of looks like he's doing a triangle, only not. Yep. I think I mentioned that. I mentioned that just only a bit ago about the pen, but no, it's no problem. So, right. Let's go ahead and change that. I want to make this bigger. What about making it like 100 instead, just to show it off? Right. It kind of looked like a triangle. It was only actually a couple degrees off, so we couldn't really notice it. Painter.speed 0. Right? Oh, but I should put it below here so that it knows it's a turtle. So now that should be super fast. Oh yeah, it just kind of went zoop and did that. So the other bit was to do this one, painter.red. Same. So I honestly, it's a matter of just copying and pasting this block over here. Changing the red to the blue, and I'm going to put this to 200 again, just to make it. Oh, I had a turtle.done there, so move that turtle.done. There we go. And it kind of creates a circle around that. That's pretty nifty. What if you use different colors? You can always try to guess what color the turtle module can support, but if you want to be surprised, we want to use the color picker instead. So colorpicker.com, but let's talk about it. So we can grab a color. Let's say we want to use, I want to use something a bit like this blue. Okay, and I'll throw this in over here instead with the hashtag symbol, I guess it's called nowadays. 398199 and run it. Wait, what? Why does it? What? Huh? What is this? What does this number even mean? Yeah, but how does it know? How does the computer know what that is? Right? It's actually a standard format for these colors. So color these days is so we define color as having 3 values. And color, by the way, is complicated. Yeah, exactly what it is. RGB. Color is very, very, very complicated. But suffice to say, because also your screen is different than my screen, and it's going to display screens differently. In fact, if you're a graphic designer, it's a bit of a hassle finding a laptop that tries to get you like very close to color accuracy. But you've got 3 attributes. You've got RGB. Now those are 3 colors. So any guesses for what the R is? Red, green, blue. How much red, how much green, and how much blue? Okay? And they're using 2 digits. Specifically, they're using 2 hexadecimal digits. So let's see what 00000 is. So 0 is the most intense amount of color.
Or F is white.
So F is white. But why F? Right? Because we're using hexadecimal. So, as opposed to decimal, right? Decimal digits use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 as our digits, right? We have 10 possible values for our digit. So, right, we've got, as I mentioned with how binary works, right, you've got the tens place over here. So you've got the ones place, the tens place, the hundreds place, right? So 352 is really 3 times 10 squared, 3 times 100, plus 5 times 10 squared, 10 to the first power. So 300 plus 50 plus 2, right? That's what that means. So hexadecimal is 16-bit. So I'm going to use a much easier number and convert it 50. So I'll just go with 52. So this is a 16 to the 0th power, which means that this digit is just 2 over here. But this one is 16 to the first power. So this means it's 5 times 16 if we wanted to convert it to decimal. 5 times 16, which is 5 times 16, so 50. So 50 over here plus 30, so that would be 62. Sorry, this is 82 in our regular system. Now, why in the world did we do this? Well, we also have, because it's hexadecimal, we have 16 different values we can use for digits. 5 more. A, B, so 6 more. A, B, C, D, E, and F. With A being corresponding to 11, 12, 13, 14, 15. So it's 10, 11, 12, 13, 14, 15. There we go. Okay? Yes.
I stabilized it, but it still can't find forward.
And you're running a Mac as well.
The only thing I'm having trouble with is turtle.done, so I just stopped using usequid instead. That
Interesting.
I have no problem through PK though.
I will work with you on this, okay? You can also try using Python 2 for this if you wanted to. That should be fine. So in this case, basically, if you see something like F0 as a color combination, that means that this is 16 to the first power plus, so 16 to the first power times 15, which is, let's see, what is that? 16 times 15? Anyone? So that would be 160 plus
240.
So it's 240. So 240 and a 0 over there. So the highest value you can get is so these colors take a value between 100 and 250. Sorry, between 0 and 255. So over here, right, you've got this value here, so we just simply copy the RGB value out. Now, the other way we can do this is that we can actually specify that. What's really fun, though, is that I can actually... So the default way that this handles stuff, though, is that you can actually put in 3 variables. Okay? So pen color args, return or set a pen color. So there's an alternate way by default that lets you to do it, which is that you give a value of 0 to 1. So I'm going to put 0, 0, 0 here and run it and show that that works just fine. It's all black. And then if I do maybe 0.5 over here and then 0, 0, it's a darker red. Let's go ahead and do, let's make this blue, so maybe 1. Oh, RGB, so green. Yes?
Is there a way to randomize the color?
Yes, there are ways to randomize the color, which just means that you need random numbers. But there's also ways to incrementally change the color, which is what I'm getting to right now. So this is a value between 0 to 1. And that's normalized. That's kind of an annoying way to do it. So I'm going to go turtle.color mode. This is what I spent like 20 minutes yesterday figuring out. Turtle.color mode 255, which changes everything to be dealing with the classic a value between 0 and 255. So here, if I put 0, 0, 255, that means that I want a really intense blue over here. Okay? Basically as blue as we can get on the screen. Okay? So what's cool about this is that we can also So long as we don't yield a value that's more than 255, we can start changing the colors using I. So let's go ahead and say, rather than using painter.paintColorRed, what I'm going to do is I'm going to say painter.paint, assuming I can type painter.paintColor 0, 0, and then there's going to be 50 of these things, so maybe 50 of these things, so 4 times I. RG, oh wait, we want it to be red though, so we'll put it in the first one. So, and watch what happens over here as we do this. Oops, painter has no attribute, pen color. So as we go on, it became more and more red. So notice that it's got a combination of black and red in there. Let's go ahead and do red and blue together. 4 times I. And it became more and more violet as we did that. Let's go ahead and give it a base color. Let's say we want it to be 50. Right, we want it to start at 50. So we want it to be already a bit reddish bluish together. 50 plus 50. And then we're going to add to it so it becomes more intensely violet as we go on. So that's pretty cool. Variables. So this is a good example. What if we want a shape with 16 sides? How many degrees should we turn each time? What if we want a shape with 15 sides, right? Rather than trying to figure that out ourselves, which is tough, as some of you might have figured out, figuring out shapes is tough, right? We can use variables and use a formula over here. So let's take a look at this. And this is a program that's going to help us draw shapes that are, I think, equilateral. So let's go ahead and create another one called, let's call this one Turtle Shapes. I just had an idea that you can probably go to Runestone Academy to one of those online renderers because they render it online. Right? If you go over to, they've got this box right over here that you can run. You can just dump it and run it in their web browser.
All right.
Because it's using HTML5 to just draw everything. Okay. So let's go ahead and grab this one and read through it. So, all right. So this one is, first we're going to import our turtle. Oh no, this is from the wrong window. Yeah. Okay. So first we're going to create a turtle called, we're going to create a turtle. We're going to create a polygon, and I'm going to rewrite this as a function, I feel. So num side length, angle is 360 divided by 9. Okay. So let's go ahead and create functionize this instead. Let's call this draw regular poly for our regular polygon. We want it to say, and we'll have 2 attributes. One which is sides, how many sides the polygon has, right? And another which is how big we want it to be. So in other words, how many sides does it have and how big is it going to be? So the first thing we need to figure out is, so let's see. So we use, and then I'm just going to continue from there. Angle is equal to 360 divided by the number of sides there are. And then so also we need the turtle up here. So for I in range sides polygon dot move the turtle forward. How big did we want this to be? and then turn him polygon. Okay, let's go ahead and call draw regular. Let's go with something again pretty easy to figure out. Side, 3 sides, 90 degrees. Sorry, size 90. That should be a fairly easy to recognize shape. I'm going to go ahead and actually increase the side length to be maybe 200 so it's easier to see. And let's go ahead and do polygon dot shape turtle. Let's go ahead and make him a turtle again. And polygon dot pen size, I believe it was. Yeah, let's make it a thicker line to draw. There we go. So that drew a triangle. How did it draw a triangle? Why did it draw a triangle? Well, let's go ahead and say this. So I said that I want to draw a polygon. So regular polygon. Let's go ahead and look at that. What that means. Regular polygon, right? A regular in Euclidean geometry, which is just a fancy way of saying the normal geometry that we typically work with, right? It is a polygon that is equiangular. In other words, all angles are equal in measure, and equilateral. All the sides are the same. In other words, it draws anything that's one of these basic shapes. A triangle with all angles being the same. Or square. Or a pentagon. Where everything is the shape. So basically it's your classical shapes that aren't that hard. Right? So a regular polygon has... So this one I get to define how many sides it has. So if I say 6, it's going to draw a hexagon. How does it know how to do that? All right. So the main thing is that every single polygon, right? So basically, how many degrees in a circle? There's 360 degrees, right? That's right. You don't have to know too much geometry in this class. This is fantastic. 360 degrees. So if you remember from triangles, right? If you've got that, all this they have to add up to like 180, right? So internally. That means like the turtle needs to make 3 turns that are exactly the same. He makes 3 120 degree turns, I believe. Yep. So what we're doing over here is that basically we're saying how many, but basically since we have a regular polygon, that means that the turtle has to turn an equal number of times between each steps. And then if he turns a total of 360 degrees and moved forward, exactly once for each slice of the circle that he does, then he's going to get, he'll draw a round shape. So what's interesting here is if I create a 360 degree shape, let's see, this might be too big, I think. Yeah, it's too big for this. So I'm going to go ahead and do 360 degrees. This is going to look actually pretty interesting. It takes a while for him to do it, but he drew a circle, right? Took him a while. Well, actually, it's not actually a circle. Let's see if I can't. So let's go ahead and do polygon dot speed 0, right? Speed it up a bit. See, that makes him only go marginally faster. And then let's make it a bit more apparent. So 6 over there. You see, it's not actually fully a circle. It's a bit jagged, right? Part of this is because that the way we're dealing with this, right? It's really hard to draw a circle. Like, you've never actually drawn one, even if you've used a protractor, because there's some jaggedness, whatever you're going to do. And that's exactly what's going on here. We're not getting like that ideal perfect circle. Because he's moving forward 6 steps, then he's turning a single degree. And then he's moving forward another 6 steps, and then he's moving another. So it's not, it's so it's close enough to a circle for basically all intents and purposes. But actually what he drew is a 360 Gon, right? Something that with 360 sides. But the more, basically the closer to 100 but the more sides you add to this polygon, the closer it's going to look to a circle, right? We went from 360 to 180. This is the 90 Gon. Still looks like a circle. Let's go ahead and look at a 45 Gon. Still looks like a circle. Let's make it look a bit bigger. 20. Right? Bit jagged over here, though, you can tell. Let's go ahead and look at a 20 Gon. And you can start to tell here that, especially if we bump up the size, that it's actually not a circle, right? It's just a bunch of close things. So it closely approximates a circle, which, if you've taken calculus, you might understand what I'm getting at there. And if you're not, you still understand it because it's not exactly a large concept there. So this is pretty cool. So let's see, nested loops. So this example I like because it's going to do something we haven't done yet. Look at that, dots. So this will make a matrix of dots 5 dots wide and 7 dots high. So 5 by 7 dots. Try experimenting with the variables. So try this one on precise, right? And notice we've got 2 for loops in here, okay? So we've got turtle. We've created our turtle. We've got dot distance, which is obviously right. A lot of times, when the code is nicely written, by the way, you can kind of figure out what it means just by the variables. Dot distance is equal to 25. Ah, that must be how far apart all the dots are from each other. Width, well, that's 5. Well, there are 5 dots in the expected output, so that's obviously how many dots are in the output. Height, 7. That's obviously how many dots high we have. Oh, interesting. And then we have the pen up command. What is pen up? Let's look at my documentation. Pen up. Yep, it pulls the pen up. There's no drawing when he moves now. So 4y in range height. Do this. Surat dot dot. A dot command. What does that do? Forward. I bet you it creates a dot. It creates a dot at that location, right?
Oh, you can stamp the shape.
And you can stamp something else too. So it creates a dot, he moves forward, and then he creates another dot. So here, the turtle he's not using a pen. He's kind of got his pen, he's got it held up, and then when he uses the dot command, he puts it down, right? So 4y in range, at the height, first thing he does is that he does this command, 4i in range width. Put a dot down where I am. Move forward the dot distance, right? And I'm not dragging my pen so you don't see me. So he puts a dot down here, then he moves forward, puts a dot down here. So he does this with number of times. So he does this 1, 2, 3, 4, 5 times. He's done with that. Then it tells him to move backwards, dot distance times width. So it tells him to move backwards 25 times width. So he moved forward 5 times. Now it's telling him to move backwards 5 times all at once, right? Tell him to turn to the right, move down a dot distance, turn left so he's facing this way again, and then he restarts, right? And he does that he does that for 7 rows. So what nested loops are really good for is for getting these kind of basic 2D kind of graphics done, working in 2 dimensions. So let's go ahead and, so I've assumed you've been working on that one, so let me go ahead and create another one. I'll copy paste this one, new turtle dot. I could have copied these and pretended these were mine, but why? What's the point, So here, right, he's putting those dots down Pretty cool. Now if I do this one, and let's say you mentioned there was a stamp, so let's see what happens if I do a stamp instead. So he creates basically a picture of himself when he does that. So let's go ahead, if I change my turtle into a turtle, shape.
What is that? Zero.
That's just the name he gave to the turtle. He's been giving all the turtles different names.
Oh, it's a person.
Yeah, it's the variable.
No, the Sirat is a person. It's a person.
Mm-hmm. Ah.
A French name.
Oh, there we go. So now let's go with distance 50 instead of 25. So the main thing that we found out while you stepped out was that the dot distance. So here is this command pen up, which does exactly what you think. The pen's normally down, dragging along it. This raises the pen. And in the code, they have the dot command instead, which says move your pen down and make a little dot. I've got stamp, which means basically pretend the turtle's covered with ink, and then he just belly flops in that location. So he creates a stamp of himself down there. Okay, so let's go ahead and see what if I add in a slight perturbation to this. Right 95, left 95. Well, that's cool. So what happened there? I moved Sirat right 95. I had him move backwards. So I had our turtle move backwards. Okay. And then I had him, he did his full thing where he moved forward. And he put down his stamps down of himself. Then I had him move backwards, right? Then I turned him right 95 degrees. So he goes from, being in this, from your perspective, from being in this direction to not 90, but just a bit more than that. And he goes forward, a bit. And then he undoes that, so he goes back to where he was, the angle he was. So he's now facing straight on and does this again. Right? So I had him move. So because he moved a bit further to the right here, well, if we remove the pen up command, which I can do just from that, we can follow him along a bit better. Right? You can see how his path is going not 90, but a bit more than 90, which means that when he starts here, he's a bit off center.
Is this how embroidery works?
Kinda.
This is what we used to do for embroidery.
Yeah. So let's go ahead and instead like do a bit of, so let's make it a bit more apparent, like 120. Okay. So, right, and let's now instead make it, instead of like having them all be that, let's make it a bit like off center. Like he's, like we want him to be a bit more, let's see. Like I want it to be like having two rows. So here, and then I want this third row to be over here, right, in line with with our original turtles. And then the fourth line to be in line with the second line. Right, and just have that pattern repeat. So let's go ahead and see that. Like that means that basically, if we're on an odd row, in even row, we want it to do one thing, and if we're on an odd row, we want it to do another thing. So we can do that with an if statement. So if row, let's say offset is equal to 0. If row, so if height, if y, which is the row we're on, is mod 2, right? That's how we'll tell if we're an even row or not. Then we'll go ahead and do offset equal to 30. So let's see what happens there if we do this. So now we'll just do, and so now we can play it with this. 90 plus offset. So sometimes we're going to move 90 degrees, sometimes we're going to move this. Now this won't draw what I want, but it will get me much closer because I know what I need. So now what is he doing? He's like doing 2 in a row, right? He's got 2 of the same column, then 2 of the same column, then so 2 rows that are the same, then 2 rows that are the same. Why? Because only every other row does he go that extra angle, does he go that extra 30 degrees. So he needs to turn 30 degrees this way. Then I want him to turn 30 degrees this way, in other words, to get them lined up. So that means offset should really be negative 30 on some rows. Let's see what happens over there. So now it's switching between 30 and negative 30. Right? So it's just switching between them and alternating them. Oh, and now let's go ahead and put the pen up again so that we can see this. And now we've got basically an alternating turtle print, which is actually pretty cool. We can mess with this a bit more. 45, what?
Those would make nice socks.
It would actually. So 45, we can, so this is at 45. Let's see what else we've got over here. So now let's go on with the next guy. Let's go on with one more example, with the last example before we do this. So jumping around and changing speed, this is the last thing we can do with the turtle. So turtle.setPosition XY teleports the turtle. Okay? So the turtle starts at 0, 0. And I believe that this uses regular Euclidean geometry. Okay? Which sounds weird, okay? Because most graphics don't actually use regular Euclidean geometry. Well, I mean, they do, but they don't use the regular coordinate plane. Here we've got the coordinate plane, so if we've got, let's see, so let me go ahead and just, print Seurat.pos. That will give me the position of Seurat. Right, after this is done. Okay, so he's at a negative y coordinate. So moving down is exactly as you expect. Y is negative here, y is positive over here, positive x, positive y. Now the reason being is that I had to check that is that in most graphic applications, the screen 0, 0 is over here in the top left corner on computers. So this is 0, 0, and then this is your x coordinate, and this is positive y over here. Positive y is down. in most graphic applications. So that's why I had to check, but that's not the way it works in Turtles because we're doing a top-down view of the turtle. Okay. So you can have the turtle teleport by giving him an XY coordinate. 0, 0 just plugs him back into the center. Oh, and you have to make sure the turtle's pen is up because otherwise he'll teleport, but he'll drag the pen along with him. So if the pen isn't up, it'll draw a line there. And again, as I've shown, you can change the turtle speed by setting it to 10. Really, to 10? Oh yeah, 10 is the fast one. 0 is the slow one. Okay, so I mixed that up earlier. 10 is fast. Set speed to 1, turtle will go really slow. If you set the Z to 0, it will go to warp speed and go as fast as you can. So that's interesting. Speed cannot be lesser than 0 or greater than 10. So this one's called Ninja, which draws something really interesting here. So this is going to go really fast. So so that lets me name the program, give the program the name, I guess. So I'll paste it in. Oops. But for once, I actually get to name a program Ninja Turtle, so that's pretty cool. And no, the entire lecture has not been leading up to a terrible Ninja Turtle pun. So, Ninja. That's good. My wife won't. Okay, so here if we run this, it's going to go really fast, right? Where it's doing this weird thing. Okay. I mean, yeah, we see the expected picture right there of what it's going to look like. So what's it doing? It moves it forward 100 distance, then it turns right 30. then it moves forward 20, then goes left 60. So let's go ahead and slow that down a bit, right? So we're going to go ahead and slow this down so that we can see. So what he's doing is that basically he's going back to the center. He's drawing a line, and this jagged line segment. And what happens after he's done with drawing that jagged line segment is that he goes back to the center every single time. So let's go ahead and look. So here's the going back to the center bit of code, okay? So going back to the center, he says pedump, let's go back to the center, put my pen back down, right? So literally he's like just putting his pen up, jumping back to where he came from, and then he just turns 2 degrees for the next bit of instructions, where he draws a line segment. So to draw that line segment, he draws forward 100, so you notice he just went forward 100 there. Then he turns right 30. Boom, he turned right 30. Then once he's there, he turns left 60. So he basically turns back to going straight again and then overcorrects another 30 degrees, moves forward, and then goes 30 right so that he's, again, facing straight out from the center, right? His last step is to make sure that basically his back is parallel with this original line. So now, again, let's, again, set the speed to 0, and we can see how quickly it draws, right? And it goes very fast when you set the speed to 0. Okay, and there's a number of things there, so we can actually start playing with the color, I think. So let's go ahead and do that. Ninja.pen color, right? And there's 180. So let's say we need to do turtle.color mode so that we can use 255 color. So let's go with so let's go ahead and say the red is equal to the I, the green is equal to I divided by 2. And that should probably be an integer. And then I is equal to 50. I plus 50. And let's see how this colors this. Does it? Or am I making it too gray? Oh, there we go. Starting again to get more. So it started black over here, and it's getting a bit more purple as we go. Alright, and I'll leave you with one more example for turtle graphics over here. But notice that we're making very intricate graphics by basically saying, just repeat doing this a bunch of times, right? That's kind of the point. We've been learning about for loops the entire time here, where basically we just repeat this over and over again and then modify it a little bit. And the color is a great way to mess with that. There's one other color command which is pretty good over here, and I'm going to adapt this one over here because they're doing this. So I'm going to take this and I'm going to translate this into the syntax we've been using over here. So let's go ahead and do, call this one turtle star. So I'm going to go ahead and convert this into the syntax we've been using so far. So I'll explain another time what from turtle import blank star means, but I want to import turtle. Okay, so the first thing we want to do is say Bob is equal to our turtle. Okay, and then we're going to set Bob's color to red yellow. Wait, red yellow? So let's go ahead and just uncomment everything else. Whoops. Let's go ahead and comment everything else out and just see what having 2 colors does for us. Okay. Okay. And turtle dot done. Okay.
What's ABS?
ABS is absolute value. So I'm going to change Bob's shape to turtle. Bob.shape turtle. Okay. I'll be translating this code a bit more. before, so you won't be able to run that yet because unless you run it exactly like from there. But so it gave him yellow outline with a gave him red outline and he was filled yellow in the middle. So let's actually go ahead and move him forward and see what actual color he does. Bob dot forward 200. Okay. And this is one really cool command that we're going to use. The bob dot begin fill and then bob dot end fill. Right? Because right now we've been doing with drawing outlines, really. This will enable us to draw actual like colored shapes. So let's just draw a triangle here for I in range 3. Bob dot forward 100 left actually yeah Bob dot left 120. Oh right, forgot that here. Vector? I don't know. It's using tkinter. So look at that. So we drew it with a red outline and filled it yellow, which was the turtle color. So let's go actually and see Bob dot space. What kind of things? So if you press Control Space here, we can see there's actually a bunch of stuff. Color args. So color can take two variables, one for the turtle and one for the pen, and then fill can be used to basically fill up a shape like that. So I'm gonna keep what we have. I'm gonna comment this part out and just show you this last bit over here. So while true, and all we need to do is Bob dot forward, Bob dot left, Bob dot position, break. So this is an infinite loop typically, right? When you do while true, it's just going to run forever. But in this case, it's doing something else. It's drawing its outline. He's moving forward 20, then turning left 170 degrees. And if Bob dot position is less than 1, that's interesting. Break. Oh, what did I got an error there. What did I do? Turtle has no attribute done.
Do capital D.
I think I had oh, I forgot to do the begin fill too. That's why I didn't. Bob dot. I think I just have to do turtle dot done here. And Bob dot begin fill. So here he goes again. So let's go ahead and we'll go ahead and inquire about position in a second. So now we tell him to, once he's done with this, we tell him to end filling, and it filled up, and it filled the entire space the enclosed space that he drew with yellow. So what is his position? Bob dot pause. Print Bob dot pause. Or not. Yes, I want to kill it. So if I move, so let's see. Bob dot pause should return pause returns a position, right? POS. It gives, that should return both the X and the Y coordinate, right? it returns a tuple. It returns both the x and the y coordinate. So ABS in Python is the absolute value. It's a built-in function. It returns the absolute value of the number. And if it's a complex number, the magnitude, it can be integer or if it's a 2. So if it gets 2 things, then it returns the magnitude. In that case, it's like a vector, which is not math that I really care about going into right now. It gives you the magnitude of that. And at some point, if he's basically gone too far out, so if he's gone basically too far back inside his path, then he's done. So that's our turtle graphics. So I'm going to write up an assignment for you guys to do some turtle graphic stuff for the for loop stuff. And let's see. So we've got plenty of time left over, I think. What? Yep, take a break. And then I think what we're going to do now then is I'm going to give you the chance to work on the for loop assignment.